CEO of CAD Infield Skill Development Center, and I'm working in field of digital marketing. I started my career as software developer, worked with various multinational companies. So first of all, we'll start for our session. I would like to warm welcome to you all, and thank you for joining today's biggest online session, which on authentic engineering on your fingertips. So very warm welcome to all. This which is organized by CAD Infield Technologies Pune in association with Dassault Systems SolidWorks Corporation. As we all know that COVID-19 is taking so much from every one of us, but it's all giving us something special also, like the opportunity to work together, to learn together, and to grow together. So CAD Infield has initiated this free online training course with certification for the young graduates, college professors, and working professionals in association with Dassault Systems SolidWorks Corporation. This is not a marketing event. It's an core fundamental training for the students and professionals. We promise this training could not be a marketing event, but this is for new learning, then market awareness, skill development, interview preparation skill set for the freshers. So I hope you all will enjoy this session as well. Thank you so much. So now I would like to give a brief introduction about our host, who is Mr. Atmaling Narayanpure. Is a founder and CEO of CAD Infield Technologies Pune. He is a passionate 3D CAD user from last 14 years, certified SolidWorks expert, CAE and international professional presentations also. He has implemented 3D CAD user from last 14 years and KBE Parametric solutions over 400 companies across the world. He studied mechanical engineering and the postgraduate from mechanical manufacturing process engineering. He started his career with Pari Robotics as design engineer for 2 years and worked with Mark Group, development partner for Dassault Systems SolidWorks for 10 years. He has participated and presented various technological topics to a number of Dassault Systems events in India and worldwide. He has a rich experience of design, standardization, and customer interaction. He also rich experience of working in India, USA, Asian, and Gulf countries also. He also supporting various customers on SolidWorks best practices, technologies trends, design automation on CAD/CAM and CAE. He also writes the blogs on technological topics, published various international journal paper, participated and presented technologies in various international events. His blog and video channel is highly recommended in CAD/CAM industry. So let's welcome Mr. Atmaling, sir.
Also. So to start with, very good evening all. First of all, I would like to thank you all for coming and joining here today. Be pleased to welcome you all for today's training. Today's date is a special date. It's the 20th May. As a traditional, it is an Guru Pushpamrit Yog. I'm extremely happy and proud to welcome you all, and I'm also happy that there are many college professors, teachers, few of the directors from across the company has joined this session. They also taught me, guided me, mentored me in a very initial phase of my career. We also are very proud and able to host for today's session, and we like to express my gratitude to all who basically help us to make this event very smoothly. I also thanks for Dassault Systems SolidWorks for their extended support on it. You have chosen to be the part of this training session, and it's my promise to you people that this next 7 days will be have a enormous learning for you people. Your passion help us all to come together instead of the COVID pandemic, and I assure you, you will gain a great career path from this. During the next few days, you will be getting to know more about the different technological topics as per the industrial requirement. So to start with, we already had shared the agenda with everyone. If you fail to receive an agenda, you can take a note of it, or just update us to our team. We will share you the agenda for entire 7 days. The purpose of sharing the agenda to you, when you have a clear agenda, attendees as well as presenter both are focused and committed on their deliverables. This assures everyone right up from the stage, and your presentation and the content will also be smooth. To focus more on the agenda part of it, we have categorized the agenda in design fundamentals, SolidWorks CAD. I request please mute yourself. I'm getting some voice. Yeah, yeah. Please don't unmute yourself so that it will create certain disturbance. So we like to focus on different categories. For example, CAD, parametric design, because industry is nowadays are moving towards or already started moving on parametric design. People also looking for a design calculation, and nowadays they want a multi-tasking person, multitask in sense of the people who can work in various domains and skill sets. All topics are designed in concern with the industrial requirement and the experience what we have it for from last almost 14 plus years. We have two sessions. You can also be participate on the hands-on challenges, where this specially designed for you people to ensure that whatever the knowledge you gain during this session, and if you have any queries and questions, you can update all those queries and questions on it. We also has created a few WhatsApp groups. You can participate on it. If not, if required, in a few sessions where a hands-on practice, queries, handling and all, that will be taken care during the hands-on challenge session. Today's focus will be on parametric design, CAD, user interface and drawing understanding, which is the core fundamental skills as per the industrial requirement. I will also like to brief you about a few things. Last almost 10 plus years, I'm helping or selecting candidate for my team, also a few of my customers. During the interview, my experience is that candidate are used to knows many things, but they unable to interpret the right answer at right time. So I have given you three icons here. Basically, these are, I called it as your soulmate. Okay, that's the slide represented. This is basically ideally suited for the students, those who are looking for the new opportunities, job opportunities during their career. I especially mention the students because there are few working professionals also joined for this session. It's another soulmate. It's something which is very close to you. It's we called it as close friends. Today, this three graphical arts is a pre-made icon used to illustrate the importance of industrial requirement challenges where you struggle. Okay, there are the icons are highlighted on a particular specific slides. so that you can take a note of it. Yes, this question is extremely highly important as per the interview point of view. This many times I come across that interviewer will ask some tricky questions, and people are getting got confused during the interviews, and it may create chances of failure. So there are few things are added where people get confused. Okay, I have also marked a few slides over it, and there are something which you always need improvement, which you have to showcase during the interview. That's we called it as a smartness, your knowledge, or in Marathi we want to have a moke pe choka. So we need to do this. So sometimes this symbols are added in combination, so that you can check out the gravity of that topic. Okay, and this also creates the multiple effects on it. So to begin with, let's move forward for this. So here hope the first icon will important interview question, confusing icon, it's confusion, and showcase of skills. So these are the entire things has been divided into three segments. So today's key learning will be focusing first on engineering drawing, then what is the key characteristics of the, what is feature based, what is parametric modeling, why industry in demand of parametric modeling, can parametric be learned, what the tools and techniques required to acquire the knowledge related with the parametric. We also focus on basics, geometry, shapes during the entire curriculum. So we also like to highlight this related with the CAD topic, where what are the sketch-based features, what are the features which are responsible for applied features or on a top of features. So it is called it as applied feature. So I would like to brief you some terms of it. Apart from this, I would also like to highlight the user interface of the SolidWorks, and you will also get the key highlights of the, and very important, I will call this as a very important skill set, which is called it as a design intent, and how this design intent is important in current industrial requirement, that I would like to highlight to you people. Then finally, we like to summarize with dimensioning methods, and we also like to conclude the many part of it through summarization. So these are the few things which I would like to highlight, and there are few. I have also mentioned that this is the very important things as far as the initial skill set and understanding of the CAD and parametric is required, because traditional CAD is now absolute. Now you need to think about the parametric CAD. So let's click, and we start related with the engineering drawing. So basically, you people know that engineering drawing is mostly commonly referred to the as engineer graphics in your curriculum. So there are various terms include in industry for engineering graphics. So engineering drawing mostly communicate the information about an object. Engineering drawing is the most important aspects of the mechanical engineering, as it is the fundamental needs which required to design and develop any component, any single component for a machine or a mechanical system. Engineering drawings has been renamed with very different terminologies. Okay, in industry, few people will call engineering drawing, few people are called drafting, engineering drafting, technical drafting, mechanical drafting, technical drawing. All are names as the same names, but during the modeling test, many times I saw that people used to get confused if they mention that, okay, this is related with the you need to create a technical drawing. So he get confused. What is technical drawing and what is the graphics of it? So these all are the names are same. We also have a very handsome images on it. Okay, imagine if suppose engineers, a mechanical engineer, do not know the language of engineering drawing. So can we communicate our ideas through words? Can we communicate our ideas with the help of picture? Think on it. Think on it. So that's why the important soulmate for you during modeling, during any as a mechanical engineer, this is must for you. Okay, as a mechanical engineer, you must have an very extremely high idea, imagination, skill sets for a engineering drawing. Let's focus on a few more terms for this. This basically important. I will call it as an important takeaway. We always let's concentrate on the subject or the topic which is more and frequently required for industry. I do respect to all my teachers who taught me 40 plus subjects during the engineering. But being a mechanical engineer, being a design engineer, I work with almost in application field, so almost 400 plus companies in across India and across the world. My first ABCD up to Z starts with a single lesson called it as an engineering drawing. Okay, I remember the days where I struggle a lot with imagination during initial stage of the career, and I know the gravity of learning of engineering drawing. So my sincere request to focus on this. Here I have mentioned a very handsome quote of it. A picture is worth 1,000 words. Okay, this is the we did some alter to this sentence, but a good drawing, a good engineering drawing, even worth the 1,000 words as well as the pictures. Imagine, it means if a picture can communicate the 1,000 words, engineering drawing communicate the more than 1,000 pictures. So imagine, because we can't explain. You saw few pictures, and the information cannot communicate it through words. I want to draw some machine. I want to draw that flight, which is Airbus 380, which is the largest. This is basically a largest passenger vehicle, passenger aircraft. Almost 550 plus people are going to travel into it. And how do we communicate the information through words? You can information through pictures. Is it possible? No, it can't be possible. So we need to put it the entire information in terms of drawing. So my second takeaway for you people, I suggest you relate with engineering drawing. An object that contained all your information. Okay, what exactly the engineering drawing means? Very important interview questions also be highlighted here. That basically this is called it as any component, any object. Okay, you will get all the information related with the shape of the object. Shape, we called it as geometry. Okay, we'll see some shapes and how different shape combinations we will get a different sets of geometry. We'll have a tomorrow session on it. It also highlights the accurate size dimensions. We called it as a measurement. Okay, many times interviewer gives you some paper to you, and he asks you explain the manufacturing methods, what are the symbols associated with it, how do you draw this, okay, how do you manufacture. There are lots of questions, and every time even also during the interview, people used to struggle with the manufacturing method of the same component. So he may be confused whether it is to be a traditional kind of machining, which is used to you people used to see during your college workshops, or there are few CNCs or VMC you saw in college, or it is the fabrication, casting, welding, forging, complete confusion. So by seeing a drawing as an engineer, you should be can imagine the method of manufacturing of it. And remember, dear, this is the highly important part of it. Apart from the engineering drawing, if you are doing some assembly, then a mechanical bomb, call it as an engineering bomb, how you can understood the engineering bond kind of a thing. So let's add some more focus on the drawing part of it, and let's begin with this. Your soulmates are here. So in industry, in engineering drawing, mainly there are two subsets. Now I'm 100% focusing on the industrial requirement. What I learned in my through my past almost 12, 13, 14 years of design experience, I'm trying to include those things into it. So mainly two subset of any component. When we called it as an individual component called part, who has a certain to represent the part, we need a part drawing. To represent the assembly, we need a assembly drawing. If we consider the part drawing, first you can see the image also. We call this as a machining drawing. So all the components where the parts are made up with the machining, for example, lathe, milling, planer, shaper, drilling, all those traditional machining methods, or you can call even a CNC or this, where material are removed in terms of the chips. Okay, material are removed in terms of the chips. These are the first criteria of engineering drawings drafting, which is all as per the industry standard. Next, there are few sets of drawing which we called it as a sheet metal drawing. We know that when the when any part, or we called it as a plate thickness, is less than 5 mm, when the thickness of material is less than 5 mm, we used to perform the various forming operation for it, such as bending operation, punching operation, blanking, famous. All those are famous question. Even sometime notching, lancing, perforating. Lot of there are operations into it, and where material are not removed in terms of chips, but material they used to use a bending operation for it. Okay, used to create a blank of it. From then they do the punching all the holes and all those things. Wants to remove the sharp corner, they use the notching it is. But all those where any material can't be get removed in terms of chip, but they used to form. Okay, so there is some kind of an importance of sheet metal drawing in the industry, and how to represent that sheet metal drawing is the industrial requirement. Later part of it is the fabrication drawing. We used to call it as weldment. Okay, I will showcase this to you also. Basically, you just see this structural. Okay, this allow you to create some amazing fabrication or structural drawing. You can't imagine, this cannot be made with the machining method. This kind of an structure you imagine, can you create with the help of forming? No. Can you create with the help of machining? Not possible. Even welding is an essential component of the manufacturing industry. Even machine beds, SPMs, robotics, automobile industries, there is chassis, structure, construction industry, aviation, okay, marine industry, and many more, where without the welding their work cannot be processed, because many complicated base structures, platform, chassis, building structures, gates, fences, kitchen applications, appliances, vehicles, and all there are many application, or even 70% of the application can 70% of the component across the industrial requirement cannot made with the help of machining, fabrication, all this. We require a weldment or structural fabrication for this. So this is the very important skill set is required for industry, that how do you create the structural fabrications into it? How do you create the weldment? We call it as a cut list or BOM for the all the cut parts and all. So that is also be a very important thing. Next part of it is process drawing. I have given the one example where components are going to get manufactured in a batch size, or we called it as a component are manufactured in a lot. Okay, where n number of machines are in a series. Okay, with n number of resources are allotted. Remember the days where you learn the operation research subject. So n machine, n number of resources and all. So one component is going to be fixed initially at chuck. Okay, and we have put it the one side at the chuck, the other operations will be performed on other side. by using traditional or CNC, VMC with a multi-axis 2, 3, 4, 5, even now 7-axis machines are also with there. CNC machines are there. So you need to perform the operation, but the only one thing is you will not remove the component from the machining. All the required information related with that specific operation are provided on that drawing. Okay, only related with that machining itself, that machining drawing. Once that stage is completed, we need to remove the component from the chuck. Okay, and then that component is going to get passed on to the next machine. Okay, and for that next machine, they will provide another drawing. The component is same, but they have a different sets. They have a different machining methods is required, and every time the drawing release is same. For example, I need to create a spindle, so I have categorized that. First we need a one clean cut, then turning. Okay, then next drawing. This all are the drawings. So for example, to complete the spindle, we require almost 10 to 15 drawings. Okay, so that these all drawings are stage wise drawing. Why this did? Because industry preferred that if some certain operator is working on a milling, he has to do the milling work itself. So he will not get the other information about what is the turning, what is the slot size, what is the turning size, what is the diameter size. His work is only concentrated on milling. Or suppose the operator is working on a drilling, he must be get the dimensions related with the drilling, the location dimension. He will not get the slot dimension which is required for a milling. So everything is happening in a stage wise way, and that stages will definitely help and faster the application process. Here I have given few examples like drill chuck, spindle, even there are many more operations you can see in the industry. So let us focus more on it. That what are the things are included into it. This basically what happened. Any drawing element, we have a basically view, dimension, tolerances, geometric symbols, finish, title block, annotations, and all other things. And if we have an assembly, okay, we need a we need a first bomb, their exploded views, their locating dimensions and all. But if you concentrate on it, basically the most and foremost important thing is the which drawing content what kind of an information. Because what happens if we are going through a if we are going for a sheet metal drawing, okay, apart from the view dimensions, they also require a fabrication or a development drawing, okay, which you have to learn in machine drawing. So they required a development drawing. Someone called it as a flattened view of it. Okay, so for sheet metal drawing, if you are working on a fabrication for a sheet metal, the most important things you have to highlight is the fabrication drawing. And for if you are working on a structure, okay, there is no need to put up the fabrication or flattened drawing over there. You need to provide the cut list of it. It means what is the section size, what are the dimensions are associated with it. Okay, you need to provide the bill of material, called it as a cut list, because weldment is a structure which is made of and few components are C channel, few are L angle, few are I beam. Okay, so you need the exact length where to cut. Okay, and then you will get it the entire things over there. So what is the core importance is, if it is a machining, we require a view, dimension, tolerances, geometric symbol. Okay, but for a machining, you do not there is no requirement of any flat. Okay, or for a machining, there is not having a concept of cut list. Okay, there are multi-body in machining. The concept is different, but you need to remember that if your manufacturing method change, okay, your content of the drawing is also be changed. And that things I think during academic we'll have a very less idea about this, and this is the industry requirement of it. Apart from this, I have highlighted very easiest way to understand these sizes. Okay, because many times for a fresher, company is going to ask you the just a random size for A1, but I will say tell you that only remember any one size of it. Okay, for example, normally we remember the size of A4, which is 210 into 297. Okay, and if you remember only one size, I'm sure that rest other size you can able to quickly learn it. So just A3 is equal to 2 times of A3, A4. Okay, it means what? A3 is equal to 2 2 times of A4. So we need to concentrate that if we have a 2 A4 paper, okay, and if we the two A4 paper comes together, we get the A3 size. So we know that A4 dimension is 210 into 297. So which one is the highest number of in between 210 and 297? Yes, obvious, 297 is the highest. So for A3, first dimension is the highest number of A4, which is 297. Okay, 297 into whatever the lower dimension, you double it. Okay, so here you can see my mouse cursor also. I can able to highlight those through some spotlight. Here we know that A4 is 210 into 297, but A3, the highest of this is 297. I have taken it 297 here. 210, I have doubled it. So 210 double is 420. Okay, similar way for A2, what is the highest number of A3 is 297 or 420? 420 is the highest. So take it 420 and double the 297. So 297 is doubled, it's called it as a 594, and it is goes for A1, okay, which is double of A2, and A0 is double of A1. So you need to just remember the single size, which is for A4. Okay, I'm considering the landscape size for A4, and if you know the A4, you just needs to remember that A3 is double of A4. We need to pick up the largest number from this A4, and a lower number is get doubled. If you remember this logic, I'm sure you people will remember this for a long time, and during interview also you will not going to miss this session. The most important part, I will not going to highlight too much about it. Just I will come with my normal drawing pad. The more is a projection method. So remember, this is the for a fresher. This is very important questions, that what is the projection method, because this again depend upon the industry, or now in a globalization world, many engineering services are company are working. Sometimes you are working on a UK British project, sometimes you are working on a US project, Singapore. So all the time UK people or British, they used to prefer a first angle kind of a method, but US they used to prefer other. So we'll get confused about this. So you needs to be fundamentally clear about the symbol also. Okay, you must be imagine that what is the first angle symbol, what is the third angle symbol, how to draw that one. So it's basically a custom of cone. Only understand, I will not going to give the too much of focus, but this have a drawing, this have a something kill set. Always there are two things I will tell you, which will help you people to ensure that you will never forget the symbol. Okay, always remember, this symbol does not have any dotted line. Okay, this is my first rule. This symbol does not have any dotted line in a symbol. Second thing is that always observer direction is from apex side. Always observer direction is from apex side, or whatever the frustum of cone, the smaller size of the frustum is my observer direction. We know the rule. Okay, we have a rule that if I'm seeing from observer side, okay, from apex side, okay, so whatever I'm seeing, okay, from the apex side, suppose my apex side in this diagram is basically at my left hand side. If I'm seeing from left hand side, okay, and drawing over the left, okay, or drawing over the right hand side, this is called it as a first angle method. Because why I have told you that always check from apex side, the reason behind this is, if my direction of observance is from this larger side, I'm getting this edge, okay, the smaller edge in a dotted form, because I can't able to see if my direction of observer is from opposite way. I can't see, and my first rule was this symbol does not have a dotted. Okay, construction geometry, this symbol does not have a construction geometry. Okay, so my first rule was always any kind of an custom of cone, whether your apex is at left hand side or your apex is at right hand side, use the same logic and you will pass on into it. The second question majorly asked during the interview is why second and fourth quadrant is not preferred, or why second and fourth projection method is not. So basically what happened, this have a rule of this called it as a clockwise rule. So whenever we used to draw anything on a second plane, okay, we are seeing from top, we are drawing on it. Okay, we are seeing from apex side, drawing on the VP plane. But as a clockwise rule, both these views are getting merged in second also and in fourth also. So the views are getting merged, so we can't able to use the second and fourth projection method. So this is again a very important kind of a question you people needs to remember. So let us focus on now related with the feature based modeling. What is parametric? This is the we have spent a lot of time on fundamentally on drawing subject, because I feel that if you are a mechanical engineer, this is must for you people. You must have a fair idea about the drawing, or not only a fair idea, you must be excellent into a drawing, because whenever you work, either you work with a design, manufacturing, okay, your communication language is drawing. Okay, so this is the must criteria. So let us focus on what is feature based modeling. The other name of the feature based is called it as a history based software. Some people also call this as a history based modeling. There are various researches currently going on. A model can be built by means of a feature. Okay, these features are technologically, in terms of manufacturing, we called it as technologically these features are extrude, cut, hole, fillet. Okay, where we need to add the material or remove the material from the component or from the raw material. Okay, so at present, feature based modeling is one of the most common technique used to realize the solid geometry. Okay, which is used to create the solid geometry. The CAD model are built starting from a base component. Okay, initially, if it is a manufacturing approach, we'll discuss tomorrow about what is manufacturing approach, what is a CAD approach. Okay, what industry prefers. Okay, if I'm doing from a manufacturing approach, I will take a raw material first, and then I will add one by one operations, which is basically, obviously it is removing the material, and finally I'm getting what I want. Okay, or if it is a CAD approach, we need to add the material in terms of boss. Okay, sometimes we use a revolve, sometimes we use a cutout, sometimes you will use a chamfer, shell, and all other things, and we can build the entire geometry. The first operation has to be carefully planned, because now a feature base related with the parametric, we'll see about feature base related with the parametric, and we assume, or we realize that this is the way you plan the CAD modeling strategy. Okay, manufacturer getting various difficulties, because you can create Alibaba, but Alibaba cannot get manufacturer. So you need to ensure that you need to list the component operations very carefully, so that designers can, if it is planned by designers, it is very easy for a manufacturing person to do the similar kinds of an set. So here we have a idler arm example. From idler arm, first initially we have created, this is a CAD based approach. Okay, completely CAD based approach. So initially I have taken one plane, I have drawn some sketch. Okay, later I did the thickness of that. Okay, then we have added another few steps into it. Okay, and finally I got this model. Okay, which is going to be my final idler pulley. So here what I'm doing, one by one addition, I'm maintaining my existing history. So that's called it as a feature based model or history based model. Okay, let's move on. Most important term is parametric solid modeling. Very important. That's why it's have a very high advantage. So what parametric? Parametric is a term describe the dimension ability to change the shape of the model geometry. As soon as you change the dimension value, your component will get modified. Understand? Parametric is a term used to describe the dimension ability to change the shape. Okay, and for to change the shape, we need to change the sketch. Sketches are created by using a dimension. So if we modify the sketch, automatically the geometry will get modified. Parametric modeling is also be a modeling process with the ability to change the shape and size of the object as soon as you modify the dimension. Let's see the key advantage. Okay, if we go through the advantage of the parametric modeling, is basically used to set up a 3D geometric model. Okay, the shape of the model geometry can be changed. Okay, the shape of the model geometry can be changed as soon as the parameter or dimension is going to get changed. There is no need to redraw. Okay, there is no need to redraw the sketch. Okay, redraw the geometry. Okay, and this saves a great amount of time of a design engineer. Okay, even in current globalization term, okay, people need a quotation, okay, very within a 1 day, within a 2 hours, else the competitor will kill the opportunity, okay, their business opportunity. So as a parametric, okay, I have given two examples here. One where I have shown you the line with a length and with a dimension and relation. Okay, so second time line I have defined with the help of dimension, with the help of two dimensions. Okay, so my question is very simple. Which one is more parametric to you people? So can you think on it that which one is more parametric? Okay, you can unmute yourself, and if you want to participate, you can participate. Uh, Okay, I have given the permissions. You can unmute yourself also. So you can imagine that which one is the more parametric, and then the terms called it as a design intent. Okay, the terms called it as a design intent. Anyone wants to speak? Anyone want to guess which one is more parametric?
The first
Yeah,
one is more parametric.
first one is more parametric. How? Can you explain a little bit more about it? Any language is okay. Nothing like that. It needs to be speak in English only. I'm okay with Marathi, Hindi, anything.
Okay. Due to the relation, when we change the dimension, obviously the other ones will change. Okay.
Okay. Let us have one example. Just I will change few images. Have you seen these three images? Yeah. My company is into a material handling. I will give you the practical scenario. Okay. My company used to manufacture the material handling. Okay. Basically, suppose my current object is a conveyor. I know that I will mute you so that yeah. So so that my product is conveyor. So sometime I used to get the order which is completely a horizontal conveyor. Sometimes I want to sometimes I get the orders which are related with the idler. We called it as this is gravity conveyor. Mostly people used to get it where no need to use any kind of a motor. Due to gravity, the component will going to get come down automatically. So what you will do in such cases? Because what happened if you have a gravity conveyor, okay, and you have a horizontal conveyor, same product, the only sometime you need to change the height of the conveyor, only that one side. So at that time, how can you say that your first relation will be okay. Okay, so it is completely, so to be specifically highlight the things that parametric, which one is more parametric? I say both lines are parametric. Understand? Parametric, it means what? Here we need to change the dimensions. Okay, we need to change the dimension, but while creating, we need to think about the design intent. Okay, while creating a geometry, we need to think on a design intent. What design intent means? Design intent is all about how we can get, how we can modify my existing design, how easily we can modify our existing design so new design can be very easily created. It means, suppose initially we got the order for a 1 meter conveyor length having a height of 800 mm and width as a 600 mm. Okay, it's a completely we have a horizontal. Next time some conveyor wants, instead of the other dimensions are same, but instead of 1 meter they want 1.5 meter or 1500 mm. Okay, or 1200 mm. So every time if you try to do it again and again, or if you not maintain the proper relation, not maintain the proper dimension, we try to do some changes and our entire 3D geometry will comes into a red. Okay, and then finally we think that instead of modifying the existing one, let us recreate this thing. So that's why now industry are moving towards the parametric. They are saying that we want to reutilize our data. The reutilization of data happens with the two way. The first and most important thing of reutilization is reutilization of data is your data management, which called it as a PDM. You heard about Team Center, you heard about Windchill, you heard about Manage, you heard about Innovia. Why this or even a SAP few amounts in CAD? Why these softwares are so popular? The reason behind this is, imagine if my company is going to manufacturing manufacturing of catalog product. Okay, then I want to reutilize my existing data so that if I did a few changes into it, I can able to get the next set of my order. Yes, I'm sure that there not be 100% similar order, but at least can we go closer to 90%? Can we go closer to 80%, 70%, 60%? Okay, you can see that if we go 60% similar kind of thing, how much amount of time save you will receive from it. That's why the people nowadays are moving towards the technology of PDM. They are moving towards the technology of parametric because they know that if my design intent means, if I know my product family, I know what are the things which is required for my company. Okay, if I know it in a very broad way, so while creating a model, I will utilize this one. Coming to my question is that if I know that my company manufactures the crane, imagine, okay, I have a crane slider, and we know that I have even not seen whether the two rails of the crane are at a different height. They always are flat. Okay, maybe they might be at a height of 3 meter, 4 meter, 5 meter, 6 meter, whatever may be the height distance, but there always be on horizontal. At that time, while designing that slider, while designing that beam or slider, I will always use a relation and dimension for the first category. But my company manufactures the conveyor. Sometime I get the conveyor which is a roller conveyor, horizontal roller conveyor with an incline also. So instead of angle, I will define H1 and H2. Okay, it means H1 means ground to first point height and ground to second point height. Okay, so H1 is equal to H2 is my horizontal. If you change the H1 and H2, okay, whatever will be the greater or smaller, you will get the height variation, and you can use a Pythagoras or sine theta to calculate the angle. No one calculate the angle. They used to be mentioned into the height itself. So it's completely depend upon my requirement, what my requirement is. So that's why my first question was is, can parametric be learned? Yes, parametric be learned, but for that purpose you need to understand your product first. Yeah, and this is the key skill, focus skill, and This cannot be learned in a night. Okay, this cannot be. You are very good in a software. You are very good into a tool, but if you want a parameterization learning, you need to understand the design in a more fundamental way, design in more changeable way. It means what are the earlier order of this product? Okay, what are the variation in future I will get it for the same product? So you need to think and create a model accordingly. For parametric, let us a little bit ahead of it. If you consider a parametric, there are two terms. One is driving, second one is driven. Okay, we know that driving and driven. Driving means those dimensions where user has to input. I repeat, those dimensions where user has to input. And driven means what? There are certain rules, logics, mathematics, okay, trigonometric formula, some mechanical formula, whatever may be, some science or some calculations are there, okay, which is depend upon the driving variable. For example, best example I used to tell, suppose we have a plate having a length as a 100 mm, width as a 80 mm, and we define a relation, that is length is my input, so I called it as a driving, and my width is always 80% or 0.8 of length, and my thickness is, okay, my thickness is length divided by 10, okay, or 0.1 of thickness. Thickness is equal to 0.1 of length. So at that time, suppose I have a 100 mm as a length of the plate, automatically width becomes 80. If I change that 100 to 120, okay, if my length of the plate is 120, I have defined a relation is 120 into 0.8, 96. Okay, so and length thickness is my length by 10, so 120 is my length, then my thickness automatically comes as a 12. So what happened to this, that every time no need to change, if I want to manually modify that plate, so I need to go to the all three dimensions and manually I have to do it. Okay, but if I use a relation, I have kept certain input variable, certain calculated variable, and then I have did it. A small plate, okay, having a 3 dimensions, we need to use 3 times changes. Imagine we have a conveyor. My students are used to did this exercise on a very huge platform, almost 50 plus components, and they used to drive it through Excel. They used to drive it through table. Okay, or for example, I used to give the one basic challenging problem for them. So look at the example that we need to calculate the diameter of the step shaft, okay, or a shaft, okay, raw material size. Okay, imagine a raw material size we want. The problem is something like that. We want to design the shaft for a conveyor. Okay, imagine conveyor or any for any purpose. We want to design a shaft. Calculate the raw material size. If I have a power, okay, as a X kilowatt and speed as a Y RPM. So how do you calculate that one? And based on that, first do the all the calculations manually. Then go to the catalog, whether check it whether that whatever the calculated value is to be available in a market as a raw material. If not, what needs to be done? Okay, if yes, so what we will do and select. Let's have a very interesting example into it. This is the problem. We need to calculate the raw material size where yeah, so shaft basically transmits a very this is the power of almost 200 kilowatt and 1200. Find the suitable diameter, and the maximum torque transmitted exceeds this basically what happened. You might be heard about the name as a factor of safety. Whenever we design the shaft for a ductile, almost all the time it is for a ductile material, we always consider, okay, if we know that we want to design for a torque of for example X Newton meter, so always my requirement is X Newton meter, but I will never design on a X Newton meter. I always add a service factor on it based on my environmental condition. I will either take it 2x or 1.3x or 1.2. There are 2-3 service factor. Either it is to be 1.2, 1.3, 1.4. So here they want whatever generated torque, okay, whatever calculate based on the 200 kilowatt as a power, based on the 1200 RPM, we will get certain torque. Okay, but if we design on a same torque, will not have any kind of a factor of safety. So he is telling that, okay, this condition is something like that. There is you add a 30% extra torque and then design, so that you are become more safer. So you will get it the good factor of safety and then design. And then there are a few terms which is given. So we know that we have a handsome kind of a formula where we used to go power 2 pi nt by 60. We have put it the power 200 okay kilowatt will go into watt, then 2 pi n rpm. Okay, we are getting into rpm. So we want this into everything into a Newton meter. So uh, we have taken all these dimensions. 1200 is my rpm, 2 pi nt pi we will take it standard as 3.14, and we have did the calculated, which is operating torque. We got it 1592, but what they have told that you need to multiply with 30% extra. This is basically a service factor, so that if we design for an extra, definitely it is valuable. As if you do not have any factor of safety, might be in a critical condition, your shaft will get failed. So I have added some torque factor. Then we know that this is we are doing for a ductile material. Okay, so we need to use T is equal to pi by 16 fs or tau into d cube. We have put it all these factor. Tau will get it based on the material, okay, which is already they have given is 70 MPa. We have put it all those things and we calculate the diameter. We got the diameter as a 53.19. Okay, so this is my diameter. I went to my manager and told him, yes sir, I have designed this. Okay, take it 53.19. But manager will manager will tell you that what is the purpose of 53.19. Okay, what is the raw material size for this? Okay, so this is the calculate. So you need to, this is the calculated value. Then he will tell you that design a shaft on top of yield strength. Okay, design a shaft on top of yield strength. So you need to be designed for a yield strength. It means you need to be designed within the elastic limit, because before failure happen, you need to restrict it. Even before plastic deformation, you have to restrict it within Hooke's law itself. So at that time you need to think on it. So I will add another factors for it. So these are the service factor table. This is the standard table. You need to refer as per the industrial standard, which is available with CMTI engineering data book, engineering handbook. Lot of things are there. Okay, people even in our office also these tables are provided to the students. So you need to think on this. Then we have to go for a standard things, raw material shape. Okay, and from raw material I cannot go in a lower size. Okay, if I go into a lower size, definitely I am designing for a lower, means I am already calling the failure towards me. Okay, and I also need to sleep. Okay, so because what happen if I designed it, if we manufactured it, and at the during the condition of working, if it fails, okay, you can't imagine what will happen next. Okay, I gone through various such situations, and it's very difficult time for designers. So he always think that, okay, there has been, will think about some factor of safety. He will ask to few of his senior, and then they will design it accordingly. So this is the things he has to think on it, that what is the calculation and what are the things needed. Not only calculation is important, but you need to ensure that whether the specific size diameter is available in a standard one. Even we know that for diameter of the diameter we require a coupling, we require a bearing. Okay, so what is the standard size available for bearing? So whatever the shaft we design, whether a similar a bearing, a standard bearing is available for that dimension, yes or no. A standard coupling is available, yes or no. Because if you can't use the non-standard atoms, because non-standard atom increases the cost. Okay, increases the time, increases the delay. And if suppose in service condition, if non-standard atom fails, okay, we need to either maintain an inventory, or if imagine a coupling, okay, motor gearbox coupling to suppose crane. If that imagine that coupling fails, what will happen? So but you can't able to run the machine until it will replace. And if suppose it is a custom made, it means made for a purpose. So imagine till the time you will not, if you have an inventory in a inside inventory, okay. But if you do not have an inventory, you can't imagine the way the pressure comes. It's highly difficult. Okay, so these are the terms are extremely highly important as far as the industry is concerned. So that's why I have focused on parameter feature based history. Okay, it's a step-by-step procedure. Either it is to be a CAD modeling method or it is to be a manufacturing method. For revolve or cylindrical component, symmetric component, the term is called it as a feature. Okay, that I will tell you later. Okay, but next part of it where, so for example, it comes with related with the CAD sketch features. What means sketch? It means for any geometry. Okay, and if I want to draw any geometry, I need two things. Okay, one is I require a geometry as well as I also required a dimension for it. Okay, so how we can run all those things. So geometry means we have some basic shapes. For example, we have a cylinder, we have a cone, we have a pyramid. Okay, or we need to use a combination of all basic shapes, and the combination of all basic shapes we can get it the specific geometry. Okay, so understanding of the geometry. Okay, we have a tomorrow's class will be focusing on various sketch relations, their geometry. And my first purpose, I always tell students to focus on geometry first, because if you know the geometry well, okay, you can be a very good designer. We are not interested for you people to become a modeler. Okay, so for a designer, geometry understanding, design calculation understanding is the most important criteria. A sketch-based features are those features who require any sketches to be drawn. For example, I require a plate. So I have first question whether it is to be a rectangular, whether it is to be a square. If I want to have a circular plate also, so either I need to draw a rectangle, either I need to draw a circle, either I need to draw a triangle, pentagon, whatever. I want a cutout. So whether it is a circular cutout, square cutout, what kind of a cutout? I want a revolve. Whether it is to be a single step of shaft, whether it is to be a 2-3 step shaft, what exactly. So anything which required a sketch to be drawn, that is called it as a sketch based feature. Very simple term. Okay, you initially needs to draw a sketch, that is called it as a sketch based feature. Applied feature, it means what? You already had created a few features. Understand, you already had created a few features and now you want to create a few features on top of existing feature. So I am having an existing geometry, I am having a dimension input. Okay, for dimension input, for means I have a edge, I want to do the fillet. I have a face, I want to do the hole. I have a box, okay, I want to do the shell. So either I have a geometry, existing geometry, and one dimension input which is required for a applied feature. It means for fillet, I have a radius. For chamfer, I have a dimension. For a hole, I have a M8, M10, whatever size. For pattern, what is along X, what is along Y, what is pitch, those dimensions I have it. So all those things, okay, I have a existing things. I did a fillet chamfer here. I have an existing geometry. I did a fillet. I have existing geometry. I did a hole. I have existing geometry. I did a shell. So all those things which does not require any shape, any sketch needs to be done. For here, I have to only select the edge. For here, I have to only select the face. So that is called it as a feature base. Very important term. That is also be called it as a feature on top of feature or applied feature. Okay, applied feature does not require any single geometries to be drawn. This will draw automatically. Okay, you need to select either face or edge of the component and you are done with it. Okay, very interesting, very easy to understand also. Next part of it is SolidWorks user interface. Okay, so in SolidWorks user interface, whenever you double click on SolidWorks, you will get it this handsome UI. Yeah, there is a little bit delay. Yeah. Okay. So we'll once we open the SolidWorks, this is the new interface of SolidWorks 1920, I think. Okay. So once you get it, you need to select any part of it because I want to first focus on the part user. SolidWorks is very very handsomely located. All the features and commands are very handsomely located, and they have a very initial meaning also. Once I have selected the part, I will get it one graphics UI, which is constant. You can change the color combinations and all those things. We have only one graphical area where we used to draw the sketch, part, assembly, everything. Okay, currently I am a part inside a part, so I will obviously I will create either sketch or I will create a feature on top of it. Next is every software have a menu button. Okay, Word, Excel, PowerPoint, everything. Okay, you have a file, edit, view, window, help, all options which is available. Okay, so that is called it as a menu bar. Okay, which is on top of every software, everywhere. This is common here also. Later we have some standard toolbars, because we know that on every software, if I want to go to new command, I have to go file, okay, again file, click new, and from new button I have to create a sketch. But SolidWorks have an intuitive interface. Here they have decided that instead of going from first click on file, second click on new, then it will open. Why to do that things? Okay, they have given us some handsome, which is regularly use queue. Okay, regularly use function, that is new, open, save, print. These are regularly used. Okay, so no need to go every time on a file and all of the things. So they have given these commands here. Next thing is SolidWorks also have a very handsome search interface. It means the third thing is if you want to search something, some command also. Okay, search starts from command. I don't know where a mirror is located. I don't know whether the cavity is located. I don't know whether that specific plane where it is. Okay, I'm confused. So I don't know. Okay, I know that this is I have used somewhere, but now I am unable to get it. But I know the name of the command. I can get it very easily. I want to search something online. This you require SolidWorks customer portal ID. Many working professionals, those who are in this meeting, definitely they will get this their ID along with their SolidWorks purchase. But and even in CAD Infield, we have all the online database ready for the students along with the portal, also portal access. This is available here. Even you want to search a component from online. This is called it. There are two SolidWorks online portal. One is 3D CAD Content Central, and second one is called it as mysolidworks.com. Visit sometime. Definitely you will get it. Many things related with this. So this is already available in SolidWorks, so you can pick up the any standard components such as motor, gearbox, for example, bearing, coupling, because all those things for a machine designer, for any kind of an every time I will not going to design the coupling, bearing. Okay, I need to, or motor, gearbox. I need to. There are already a lot of vendors are available, so I will pick up the right one for me. But I need exact geometry. It is for overall shape itself, so I can easily find out from there. So this is connected to online. SolidWorks is very handsomely have a first one is a command manager. This command manager is change specific to the command tab, which is highlighted in a yellow color. Okay, your screen is still updating. Yeah, now it is updated. So command manager and command tab. So every time if you select a feature from a command tab, you will get it all the commands related with the feature. If you select sketch, you will get it all the command related with the sketch. If you select sheet metal, you will get it all the tools related with the forming tool. If you select cam, you will get it all the tools related with the cam. So very intuitively all these commands and the location is very fixed. This is on your top, which called it as a heads up toolbar. Many times you require zoom in, you need to be changed these, you need to create the section view, you need to have isometric front view, top view. Okay, we need to show, hide, plane, axis, set sketches, CG, many things. Okay, or there are many shortcuts also be available, but all those things you can get it. Even you can change, you want to change the background, you want to create something new background, you want to utilize a machine shop background, everything is possible in heads up toolbar menu. Very handsomely designed, which is this is the most important one as a feature manager. This feature manager, again, it is subsets into different commands. I will go into my next slide where I will explain you in detail. A reference trade, which is at bottom, which gives the information about the plane, your coordinate system, X, Y, Z points, okay, from which you can specifically goes into the plane. If you select front view, it will go give you the X, Y. If you are in the top, it will give you the X, Z. All depend upon the this thing, so that you can get it whether you are working on a positive X or you are working on a negative X, positive Y, all those things which is related with the coordinate system. Don't worry too much about it. This is standard document window, and document window is basically where you need to create the graphics. Okay, SolidWorks always have a single document window for creating the 3D geometry, but simultaneously, if you want to create some mechanism, animation, if you want to create some motion, okay, definitely there are n number of, there is motion study 1, 2, 3, 4. You will get it even for FEA. You will get it multiple window, but for a modeling geometry, you will get it only a single environment in SolidWorks. This is the interview question asked sometime. So another part of it is here we will get this called it as a task pane. Many times task pane is used to faster the operation. Task means something which needs to be done very fastly, very accurately, very quickly. So that things we can get it in a task pane. Okay, so we are very close to our finish time. So this is the feature manager. We know that I have told you that feature manager is divided in various uh, small commands. So let's move on different commands. So one, okay, we'll get the feature design. I will open up everything, because there I find out little bit delay for you people. So I will ignore the animation, so that all tools you can get it in once, and then I will explain one by one. Let's till time I will have a one poll question for you people, so that I can take at least a small water break. Just I have launched one simple poll questions to you. I request you can just click it out as per as your choices. Last 1 minute, and I will close this one. Okay, thank you. 71% people has been voted. Any few, because still 30% people are remaining. Okay, thank you. I will close the poll. Okay, so I have taken time because this animation required some time, and there has been I observed some delay on the screen. So here you can see this first one is a feature manager design tree, which is common, where you can get it all the history of your features, plane, material, all the annotation information and all. Second one is called it as a property manager. Basically, this property manager is used when this is basically a command base. It means if you are going to use a boss, okay, which is a material addition, it will highlight the property related with the boss. If you want to revolve, it will tell you how much degree you want to revolve, or what is the axis of it. If you are going to use a fillet as a command, it will show the options related with the fillet. So property manager is always changed depend upon the commands, okay, and there are numerous ways to work on it. Next one is configuration manager. This is the new techniques where parameterization in comes, and I must say that you need to have a fair idea about this. As Basically what happened, there are n number of library components are there which cannot be separately created and saved and used one by one. Imagine if my company is a manufacturer of any coupling or suppose accessories like nut bolts, washers, and for example I have a M8 M10 as a bolt size. M10 have a 10 different varieties of length, and each time if I'm creating that component and saving that component into my design library, it's a huge work, because M10 itself have a 10-15 varieties. Then head type is different, then bolt type is different, then M8 also have different. So you can't imagine. So at that time, each and every time, if you calculate, if for each variation, if you created a single part, it means we'll have a lakhs of components for our inner library, and searching that component and reutilizing the same component again and again, it's difficult. So that's why configuration is a tool where a single family of component you can reutilize it very effectively. We have a dimension or the display manager tree. As a 5 number, it is a display manager where you can put it the color, okay, appearance on it. Fourth is dim expert dimension. Many times you need to utilize the similar created part for cam machining. I'm telling you about the cam machining, and no need to create any kind of a drawing for it. It means a 2D drawing. So all the model, you have created a model, you want to directly submit that model for a CNC machining, okay, where no need to have any kind of a physical drawing. They want a component from you. So you can auto dimension all those components through dim expert. So dim experts will give you the facility where you need to define the references, and you can ready to go with all the components and dimensions. Component will get the automated dimensions. So that's the things. Sixth is related with the cam tool, okay, where uh, various commands related with the machining, but I will not go in a detail about it. Next part of it is a task manager. So task manager is also, we have a few things where we can get it the design library, we can get it the appearance. Okay, the appearance in feature manager is related with the color only, but appearance in task manager is related with the scene. It related with the texture. It related with decal. It is related with the logo. It means you want a grass, you will get it a grass. Okay, you want some feel like tire or rubber, okay, you will get it that one. Okay, so you want some related with the furniture kind of a thing. So it gives the texture also, but whatever the appearance we saw here in fifth column in feature manager, this is only related with the color. It is related with the RGB color, but here you can add a on top of it you can add a texture also. Apart from this, we have a custom property. Every component is have some certain properties. For example, if I needs to be identified, okay, I must have my name, my father's name, okay, where from I'm located, in which city, what is so all the information related with this. So for example, any component, they have a part number, description, material, okay, then what kind of an finish it is, okay. So all the information related with the manufacturing of that specific component is to be called it as all the custom properties, which will be utilized for engineering or mechanical BOM. I will tell you in a later stage what is the difference between the engineering BOM and mechanical BOM. You also want to participate into the forums, blog. Okay, you can get it a lot of videos of mine also in a blog and video forums. So this is related with the technology topics, and also these are the tasks where you want to faster your operation, that is to be located in a task pane. And so we saw what is SolidWorks, what is feature-based modeling, what is parametric. The one term is fully associative. We called it as, it means if you change your sketch, your part will get modified. If your part get modified, your part drawing will get modified. If your part get modified, your assembly will also be get modified. Assembly drawing will also be get modified. So we are doing the changes from sketch to part, part to part drawing, part to assembly, assembly to drawing. So this is the one way of communication. Okay. If you use the model atoms, which is automated dimension in SolidWorks. So suppose you did changes in a drawing for a dimension, okay, it will change the assembly, it will change the part, it will change the sketch, okay, but it should be a model atoms only. So This gives the bidirectional associative. So fully associative means how you are connecting. It means I'm doing the changes into a sketch, but my assembly is not get modified, so there is no meaning of into it. So this is again is must. Every time you need to ensure that whatever changes applied on a sketch things has to be applied. You need to rebuild some way, some software. It is called it as update and all, but SolidWorks have a very handsome associativity related with this. You will get it easily. This we discuss about design intent, where this is the purpose. Okay, we discussed during parametric also that how the design intent creates an important role. Design intent means your model behavior once you did the changes, or how do you create an existing geometry so that once a new requirement comes, you did certain changes, whether it is to be modifying very easily or it is creating a challenge. So that needs to be very carefully planned. So that is to be called it as design intent. Design intents are done with the two things. One is two dimensions, two relations. Okay, there are two things: equation, link value, creating some logics and all. That is, I will not go in detail because of the less time. But this is must every relation. I have taken a one part of design intent which I saw. I thought that it is really highly important, which is a relation. Every sketch entity such as a line. Okay, line may be a horizontal line, vertical line, line where we have a coordinates. Okay, from where that line starts. If it is origin, okay, my coordinates is 0 0, so I must have a coincident. Okay, it means there are few sketch relation are independent. Okay, line is horizontal, it is independent, but there are few which have a dependent. It means, for example, I want a perpendicularity. So the first question comes into my mind is perpendicularity with reference to what? Okay, so I need to define a second reference for it. So whatever, or we want a co-radial, it means radius must be same. So what is the first radius? Concentric. To whom I have to do the concentric? So it is depend upon the other. Okay, tangent. So I require a circle and line. So that comes as a tangent. So we need to think on that. Or even a symmetric also be something like where we need to think on where multiple dependents are there, and we can work on a relation where maximum relation, minimum dimension, and if your design intent is allowed, definitely that is to be the best modeling practice, best modeling parametric practice is going to be get considered. There are different dimension intent are there. It means whether you are giving a pitch and one side of dimension, or you are giving a instead of pitch you have defined the end-to-end dimension. This is called it as a multi-reference dimension, or you are defining the pitch and symmetric dimension. So this completely depend upon whether your plate, how your plate is going to get modified. Okay, if you do certain changes, what will happen to this? Suppose initial plate length is 200 mm. If I modify to 300 mm, so whether I need that that plate that whole pitch remains same, or I need that whole pitch also be changed. So you need to think very small thing, defining the dimension for whole. But this completely, if you want to think on a parameterization, you think on the thing that whether if I define the edge to edge dimension, what will happen? Because if suppose I'm using a mold, okay, I have a mold base. Okay, at that time I always think that okay, mold base vary in a symmetric way. So I always use the last case, okay, which is defined as a pitch and symmetric relationship. So the way you defined it, the way you will get the results for the parametric. So understand the 2-3 things that drawing fundamental is extremely important for a mechanical engineer to grab the attention. We have some black screen. It's a presentation technique itself. Takeaway, I think we are late by 5 minutes, but to conclude the session in a quick way, we know that what is the importance of the drawing. Okay, engineering drawings, it's more work than thousands words of pictures. What is industrial drawing type? What is manufacturing drawing? What is fabrication drawing? What is weldment drawing? Okay, there are types. Okay, each drawing contain the information, different information related to it. Okay, what is parametric? Okay, what is importance of parametric? Why industry wants parametric design? Why they are going for a even it's called it as a feature-based kind of a thing, or why people are looking for a history-based software. Okay, why these things are important. Even we saw about the SolidWorks interface there. Few things or all the things are very clear to you. All shortcuts which we used to use with Microsoft. Okay, all those softwares are tightly interlinked with SolidWorks also. I have also added a few interview questions where uh, our soulmate have defined. Okay, you hope you people have noted it on it, and this will definitely help you people to prepare the things in more passionate and more core way. I'm sure this time is not sufficient to cover the most of the part of it, but we tried a lot, and to ensure that you people get the enough information about the topic. Okay, at least you will get the insight about what to learn. Okay, how to learn, what are the things which industry preferred. Okay, whenever you are doing something, you need to focus on which area, what are the areas which are important as a fresher. So all those things, it's a very basic fundamental things. Take away, like you need to be improve your drawing skills. You need to be good in basic understanding of design calculations. So we saw related with the user interface. So think on it. Definitely, it will add the great value on it. Just to remember again yourself, we will take few questions today also, and those who wants a hands-on practice on it. Okay, because I have not even